Welcome back to the deep dive. Ever wondered how thousands of planes crisscross the sky every day without, bumping to each other? Today we're pulling back the curtain on aircraft separation. It's this kind of unseen choreography that keeps our skies incredibly safe. It's an absolutely vital topic for anyone in aviation, especially if you're aiming to fly a commercial plane yourself. Our mission for this deep dive is, well, to give you a real shortcut to mastering the core concepts and the precise numbers you'll need to ace those ATPL theory exams. We've got a stack of essential source material here on aircraft separation standards and procedures, and we're going to extract the most important nuggets of knowledge. Not just the what, but really the why behind these crucial rules.
That's absolutely right. Air traffic control's primary objective, its number one job, is preventing collisions. And the separation minima we're about to explore, they are the absolute bedrock of that safety. This deep dive, it's going to illuminate the detailed standards outlined by a foundational document. ICAO PANS Document 4444. You could almost think of it as the International Bible for Air Traffic Management.
Right. So we'll be looking at, everything from how planes are separated vertically, horizontally, to the complexities of things like wake turbulence, which sounds pretty serious, and radar control. By the end of this, you'll be really well equipped to answer those specific, sometimes tricky questions about these safety procedures. Give you a real edge. So grab your mounted flight suits, I guess, and let's unpack this. Okay, so let's kick things off with the absolute basics. What exactly are we talking about when we say separation in the aviation world? Sounds simple, but I imagine it's anything but.
You've hit on it. At its heart, separation is fundamentally about making sure aircraft don't get too close. That's the core mandate of air traffic control, or ATC. Within controlled airspace, ATC ensures all controlled flights, those getting active air traffic services, are kept safely apart. Preventing collisions is always priority number one, and this isn't just for big jets crossing oceans. It applies across a really wide spectrum. We're talking all flights in Class A and B airspace, IFR flights in C, D, and E.
IFR being instrument flight rules, right?
Exactly. And it's also applied between IFR and VFR visual flight rules flights in Class C, and between IFR and special VFR flights too. Sometimes even between special VFR flights, if the authorities say so. And beyond just avoiding collisions, separation is used strategically, to space aircraft efficiently for smooth arrivals and departures, and really importantly, to counter those potentially dangerous effects of wake vortices.
Wake turbulence again. We'll definitely need to get into that. So it's not just one big blanket rule then. There are different methods, different ways to separate aircraft.
Absolutely. We mainly categorize separation into three primary types. Each has its own method, its own purpose. First, and maybe the most intuitive one, is vertical separation. Simple concept. Keep aircraft at different altitudes or flight levels. Think of it like creating invisible stacked highways up there, different layers for traffic.
Okay, makes sense. Stacking them up.
Then second, we have horizontal separation. Now, this is about keeping a specific distance between aircraft on the same horizontal plane. And this breaks down further. You've got longitudinal separation, where planes follow the same route but are spaced out along that path like cars on a motorway, one behind the other. And then there's lateral separation, where aircraft are on completely different routes or geographical locations, like cars on parallel roads, maybe.
Longitudinal and lateral. Got it.
And then there's a really interesting third type, composite separation. Now, this isn't your everyday standard. This is where things get, fascinating for those unusual situations. It's kind of a blend, mix of both vertical and horizontal separation. It's typically used in very specific, often urgent circumstances. Think of it as a compromise standard, usually agreed internationally. It allows for reduced separation, sometimes even half the normal minimum, just to facilitate a safe resolution.
Half the normal minimum. Wow, when would that happen?
Yeah, it might come into play during, say, an RTF radio telephony failure procedure, like you see over the North Atlantic sometimes, or in situations involving unlawful interference, especially if a pilot can't maintain two-way radio contact. The core idea is to provide some kind of safety buffer when maintaining...
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best